Hi guys, so we're going to proceed from where we had ended. So this is the second part. In the last video we ended on question 10, then we proceed. So this is 2022 paper 1 GCA. We start with question 11. Part A, given that E is equal to, so there is supposed to be an equals, given that E is equal to that, so we have numbers from 1 up to 10, A is equal to prime numbers, B is equal to multiples of 3, then they want us to list that. So what are we going to do? So let us start by, so do it from here. So I'll start by listing my A there. I look for prime numbers from this set. Prime numbers, these are numbers divisible by 1 and itself. So the first prime number is 2, followed by 3, followed by 5, followed by 7. So those are the only prime numbers in the universal set. Then B, we are looking for the multiples of 3. So a multiple is a bigger number in which smaller numbers can go into without leaving a remainder. So multiples of 3, they start from 3 itself, go to 6, then 9. So those are the multiples of 3. Then finally, if we are to list A union B complement, we simply mean put these two together, then subtract them. So whatever is not in A and B is what we're going to write. So check in the universal set. I'm going to list the numbers which are not found in A nor B. So that is 1, 4, 8, and 10. So those are the members of A union B complement. We proceed to the next question. On a diagram in the answer space, draw triangle Q, the image of triangle P under a diffraction in the line y is equal to negative x. So this is important. We're going to use this one to draw a triangle Q, which is the image of triangle P. So how are we going to do that? The first thing we're going to do is that we're going to draw a line that is going to act as our middle line. So in this case, I'm going to draw a line that is going to pass through the intersection here, that will pass through the origin, like that. So it should be a straight line that will go there, and that is going to extend from here all the way up to there. Then now, what we are looking for is that is the exact image of this one now on this other end. So now, if you check here, this has moved 1, 2, 3. So another one will move from there, 1, 2, 3. So it's actually going to start from here. Then it's going to go how many times? So we have this side 1, 2, 3. So it will move 1, 2, 3 times. It comes here. Then from there it is going to move up, which is the side which is here. If you are not able to see this clearly, so it's this one, then going down like that. This is a triangle. So 1, 2. So I'm going to move up, so twice, then I'm going to join these. So I'll join these. So from there, this will join to that. So now, what I've drawn now is an image, so of triangle P, that I'm going to call triangle Q. That is how you can, so it needs to be a smooth one. So that's basically how you can go about those that question. So this question is coming from transformations. We're going to proceed. We look at a different question, which is question 12. A piece of wood measures 25 centimeters long. Find the upper limit and lower limit. So how can we find the upper and lower limit? So the first thing you need to do, so this is a question on approximations. The first thing you do is you need to find what we call the least unit of measurement. The least unit of measurement from 25 is 1. So 1 is the least unit of measurement from 25. Then from the least unit of measurement, find what we call the absolute error. The absolute error is given by half of the least unit of measurement. So what is half of 1? Half of 1 is just 0.5. So our absolute error is 0.5. Then in us now finding the upper limit, to find the upper limit, we get the value we've been given, then we add 0.5. So this becomes 25.5 centimeters. In order for us to find the lower limit, we subtract 25, subtract the absolute error, which is that, then we get 24.5 centimeters. Then from there now, what we are going to do now is we just write them on the answer spaces that we've been given. So we found our upper limit to be 25.5 centimeters, our lower limit to be 24.5 centimeters. So that's basically how you can go about finding the upper limit and lower limit from absolute error. We proceed. We look at the second part of question 12. It is asking us to find the percentage error. How do we find percentage error? Percentage error is given by the absolute error divided by the true measurement that you have multiplied by 100%. So the absolute error is 0.5, then the true measurement was 25 centimeters, then that multiplies 100%. So 25 into 25 is 1, 25 into 100 is 4, then what remains, you say 0.5 multiplied by 4%. So when we say 0.5 multiplied by 4%, we know 0.5 is the same as half, and half of 4 is 2. So we have 2%. 2% is our percentage error. So you just go on your answer space and then you write your 2%. That has been dealt with. We proceed, we move on to the other question. So now, the other question, we have a question on Alright, we have a question on functions, question 13. So that is a question on functions. Given that f of x is equal to x minus 4 and h of x is equal to 2x plus 3, find the inverse of x. How do we find the inverse of a function? So this is what we do. Firstly, we know that our h of x is that. The first step you do is that you say, well, in place of h of x, put y. Say y is equal to 2x plus 3. The second step is you interchange or you swap x, you swap y with x. Swap y with x. While there is y, it becomes x. While there is x, it becomes y. plus 3. Then finally, you now make y to be the subject of the formula. You make y to be subject. So I'm going to get this. I'll write it as 2y plus 3 is equal to x. Then I'll say the 3 will cross the equal sign, so that it becomes 2y is equal to x minus 3. Then I'll say divide by 2, divide by 2, that goes, that goes. Then from here I know to say y is equal to x minus 3, everything over 2. Then I say therefore the inverse of x is equal to what I have found, x minus 3, everything over 2. So that one is the answer for the inverse of that function. Then we proceed to answer the other part. Proceed to answer this one. On B, they are asking us to find the inverse of 5. First of all, the inverse of x is equal to x minus 3 over 2. So in order for you to find the inverse of 5, what you do is that where there is x, you put 5, so that it becomes 5 minus 3 over 2. 5 minus 3 is 2, and 2 divided by 2 is 1. So the inverse of 5 is simply 1. That is how you can do that. Then finally on this one, we solve f of x. So this one is a composite function. How do we solve for composite functions? So composite functions, we have fx. Remember, our h of x is what? So if you check, our h of x is 2x plus 3. Then our f of x is, they gave us x minus 4. So now, in order for me to find f of x, so I'll get the h of x. Then where there is x here, I'm going to replace with f of x. So this is what I'm going to do. I'll say 2. Then where there is x here, I'm replacing with x minus 4. Then there is a plus 3 there. So 2 times x is 2x. 2 times negative 4 is negative 8 plus 3. This is going to simplify to 2x. Negative 8 plus 3, we get negative 5. So negative 5. So this one here is the final answer for part C. That is how you can go about functions. For those who have challenges in how to go about functions, you can get in touch with us. Then we can schedule some classes that can be of help to you. We proceed to question 14. Now, question 14. Question 14. Okay, we have. Okay, so this is a question that we have. Okay, let's look at it. This is a question on bearings. In the following diagram, P, Q, and R are 3 points on level ground. The bearing of P from Q is 228 degrees, angle QPR is 72 degrees, and R is due south of Q. Then what do they want us to find now? So let's go to the questions. They want us to start by finding the bearing of Q from P. Now, whenever you're finding bearings, this is what you do. They want us to find the bearing of Q from P. You look at the word, the letter that goes with the from. So from P, you go where P is, and you check on the north of P, you are supposed to move in the clockwise direction to go where the line that joins with Q is. So this line is where Q is found, because Q is there. This is our Q here. Then this is the angle we are looking for. How can we find this angle? We can find this angle by saying this angle here and this angle here are going to add up to 180. So how am I going to do that? So the best way for me to do that is that I can say, since a complete angles at the point here, they add up to 360, and if I subtract 228, I am going to remain with 132. So here I have 132. So in order for me to find this one, I'm going to say 180 subtract 132, and this is going to give us, if we do this, we'll get 48. So we'll get 48 degrees. So now the bearing now that this question was demanding us, so the bearing of Q from P is equal to, now remember this is a 3-figured bearing, so you don't write 48, you put a 0 so that it becomes 0.48 degrees, 3-figured bearing. We look at the other part, the bearing of P from R. So look at where R is, move in the clockwise direction to where P is. So we're looking for that one. We can find this angle by subtracting the angle inside. And how are we going to do that? So that is easier. Let's do this. Now let us look at that. If we add these two angles, now I want you to know that this angle here, the whole angle, and this angle should add up to 180 degrees. So if I add these two angles, if 2 to 48 to be 50, and 50 plus 70, I'll get 120. So 180 minus 120, I'll get 60 here. Now to find this one, I'll do 360 subtract 60 so that I find 300 degrees. So for this one, we have found 300 degrees. Okay, so the bearing of P from R, we get 300 degrees. This one is already a 3-figured. Okay, that has been dealt with. We proceed, we look at a different question. Question 15. A line passes through the points. We have point A and point B. So if this is not too clear, I can write. So I have point A. Point A is negative 2,5. Then point B is 0, y. Okay, so I can say x1, y1, x2, y2. Then they've said the gradient of this point AB, of the line AB I mean, so the gradient is negative 3. Then they're asking us to find the coordinates of B. Now for B, it is 0, y, so meaning we're only looking for the y coordinate. How are we going to find the y coordinate? We use the formula for gradient. Gradient is equal to y2 minus y1 over x2 minus x1. Alright, gradient is negative 3 is equal to, what is y2? y2 is y, y1 is 5, then x2 is 0, x1 is negative 2. Then from there, we'll say negative 3, y minus 5. Then negative times negative is positive. 0 plus 2, that's a 2. We'll say over 1, and we cross multiply. So that becomes y minus 5 is equal to negative 3 times 2, we get negative 6. Negative 5, we cross the equal sign, y will become negative 6 plus 5. And what is negative 6 plus 5? Y becomes negative 1. So therefore, in here we can say, therefore, the coordinates of B are 0, negative 1. Those are the coordinates of B. So that one has been dealt with. We look at part B. In the diagram, ABC is a straight line. Angle BCD is equal to, so there is an equal to, just in case you are not able to see clearly, is equal to 90 degrees, and tan, so this is tan, ABD is equal to, so there is an equal to negative 3 over 4. That is what we have. Okay, so let's see the diagram. So this is the diagram we have, and they're asking us to calculate the length of BD. How can you calculate the length of BD? So now, this question is coming from one trigonometry, and it is also having a part of the Pythagoras theorem. Now look at, in trigonometry, I want you to be familiar with what we call SOHCAHTOA. And here we are interested with this because we are looking at tan. In SOHCAHTOA, the tan theta is equal to opposite over adjacent. So now, here they are telling us that tan ABD is equal to the opposite over adjacent. It should give us negative 3 over 4. So meaning, here, this is our hypotenuse, this is the angle B, this is our hypotenuse, then our opposite side will be that side, which will be 3. You can put negative 3 or you can put negative 4 here, it's fine. You can leave this as positive, then there you write as negative 3, it's fine. Then from there now, we proceed now into saying, how do we find the hypotenuse? We use the Pythagoras theorem. There is this theorem which is interesting. If we say c squared, this should be the same as a squared plus b squared. So meaning, when you square the hypotenuse, so the hypotenuse squared should be equal to the square of the sum of the two adjacent sides. So where we have the opposite and adjacent, so we have 3 squared plus negative 4 squared. So where the hypotenuse is BD, so BD squared is equal to 3 squared is 9, negative 4 squared is 16. Then here we'll say BD, if I square root that, it's going to give me 9 plus 16, that's 25. And this is also square rooted. So the square root of 25. Now, for length, we're interested in getting the positive values. I know the square root of 25 is positive or negative 5, but I'm going to consider the positive value, BD, to be positive 5 units. So BD is positive 5 units. Therefore, BD has been found. We therefore move on to a different question. So we have this question, which is question 16. Question 16 is a question on a topic that we call congruence and similarity. So we have a question: two cylinders A and B are geometrically similar and the ratio of their heights is m to 4. So the ratio of their heights is m to 4 respectively. Given that the areas of A and B are 144 square centimeters and 256 square centimeters respectively, find the value of m. So look at this. That is what we've been given. So if their areas are 144 and 256, then their ratio of areas, so ratio of areas will be 144 to 256. Now I can simplify this. I can look for numbers that can go into 144 and 256, but to save on time and calculations, what I'm going to do is that ratio of areas. Now I'm interested, I can find the ratio of heights from ratio of areas. So I can say ratio of heights is just the square root of the individual areas. So the square root of 144 is 12. The square root of 256 is 16. So now we simplify these. The numbers which can go into 12 and 16 is 4. 4 into 12. So we can say divide by 4, divide by 4. 4 into 12 is 3. Then 4 into 16 is 4. So this is the ratio of height. And here they told us that the ratio of heights is m to 4. So where we know to say the 4 goes with the 4, definitely the m will go with the 3. So we'll say therefore the value of m is equal to 3. That has been found. So this is a topic on congruence and similarity. It's a grade 10 topic. We proceed to part B. The diagram below shows a square base right pyramid with an axis AB. Describe fully the symmetry of the pyramid. So this is also a grade 10 topic on symmetry. Specifically, we are looking at the type of symmetry here. Let us describe fully. So the type of symmetry that is taking place in here is called rotational symmetry. So how do you describe that? So you say it has rotational symmetry. It has rotational symmetry of what order? Of order, you check, the base is a square and the square has got 4 equal sides. So it has rotational symmetry of order 4 about the axis. So about the axis AB, so the axis AB, then and we can include the angle of rotation. Angle of rotation is, so the angle of rotation about AB here for a square is 90 degrees. It's 90 degrees. So it's easier to find that because we have 360, then we have 4 here divided by 4. So 4 into 36, that's 9. Then so the angle of rotation is 90 degrees. So that one has been found. So that is how you can describe fully the rotation for that one. Okay. So from there now, we move on to a different question. So we have that question here. Now this question that we're looking at, question 17, is a question on a topic we call circle theorem. So it's coming from a topic we call circle theorem or circle geometry. In the following diagram, ABCD are points on the circumference of the circle, center O, then BD is the diameter, AD is equal to AC, and angle BDC is equal to 22 degrees. Alright? Then, what do they want us to find? Now, this is what I do for these type of questions. To make my work easier, or sometimes before I look at the question, I can start by substituting first. I put in the missing angles in here so that I just start putting them when they ask me to start putting them. That is what I do. But again, what you can do is that you can just start answering them the way they come. So look at, like the first question, they want us to find angle BAC. BAC. So where is angle BAC? So you go back to the diagram and you look at, this is B, that is A, that is C. So they want us to find that angle as angle BAC. And what do you think is the value of angle BAC? Now, it will be important for you to note that angle BAC is the same as angle BDC. Now, angle BAC will be the same as angle BDC, which is that one. Why? Because they come from the same segment. So this is a property. So meaning this angle is also 22 degrees. So the angle is 22 degrees. That one has been found. Let's look at another question. They want us to find angle CBD. Angle CBD. Okay? Part B, they want us to find angle CBD. How do we find angle CBD? Now look at angle CBD. CBD. So we're looking for that angle here. What do you think is the value of that angle? Now, it will be also important for you to note that angle CBD should be the same as this angle here, which we can call angle CAD. Angle CAD. Those should be the same segment. Now, this one is a segment here. So these two angles, they come from the same segment. But again, how do we find this angle here? So in finding this angle, it will be easier because what I'm going to do here is, I'll know this is the center here. So from the circumference to the center is a radius. From the circumference to the center is a radius. So I know to say even here it's 22. Same radii. Then what am I going to do? I will know to say, if I want to find the angle here, I will add these two angles and subtract them from 180. So if I subtract them from 180, I find the angle here. Then what I'm going to do is that I'll know to say the angle that I'm going to find here will be the angle at the center. And there is a property which says that the angle at the center is twice the angle at the circumference. The angle at the center is twice the angle at the circumference. So we have to find this angle. How do we find this angle? Add these two angles. 22 plus 22, we get 44. Now that 44 we subtract from 180. So what do we get? So we get a 6 there, we get a 3 there, we get a 1, we get 136. So 136, so I'm saying in order for us to get this should be twice this. So now this should be twice that, I mean. So in order for me to get that, I need to divide this by 2. What is 136 divided by 2? 136 divided by 2, so I get 68. So 68 degrees. So meaning the angle there is equal to 68 degrees. So that has been found. We look at, if there is another question, that's part C. Find angle ACO. Angle ACO. So let us come back and check. Part C, they want us to find angle ACO. So where is ACO? This is A, that is C, that is O. We're looking for this angle here, that angle. How can we find angle ACO? Now, in order for us to find angle ACO, this is what we're going to do. Now look at, we have found 68 here. These two, they mean this triangle. So we have that and we have that. So it simply means that this type of a triangle, now there are three types of triangles that I want you to be familiar with. There is what we call a scalene triangle, there is what we call an equilateral triangle, and there is what we call an isosceles triangle. So this type of a triangle that has got these two is called an isosceles triangle. So an isosceles triangle, it means these sides are the same and their respective. So we have these angles. So this angle and this angle should be the same. So if this is 68, so and what remains? So we have, let's add what we have. We have 68 there. We have 22, which is 44. What is 68 plus 44? Or plus 44. So we have 2 carry 1, then 10 plus 1, 11. We have 112. Then in order for us to find this missing angle, we subtract from 180. 180 subtract 112. So this will be 7. 10 minus 2 is 8. There we get 6. We get 68. Then this 68 we divide it by 2 because the angle here and there will be the same. 68 divided by 2 is 34. Even here we get 34. So the angle ACO is 34 degrees. So that is how you can go about this question. So these are just properties. So if you're having challenges on these properties of the circle, you can get in touch with us, then we can schedule for lessons that will help you to understand. Okay, so that one has been dealt with. Then we check for another question. Okay, so we have another question there, and this is question 18. Now, question 18 is a question on a topic we call variations. It's a topic in grade 11. It's a topic we call variations. So let's look at it. Y varies directly as x. So next to that, y varies directly as x, and inversely you say over, that's inversely as the square of z, so z squared. So we can write, whenever you are writing direct variation, so now you have to put the constant. So you say y is equal to, now you put the constant so that it becomes kx over z squared. So that's the equation that we have formed from the statement we've been given. Then they are saying, given that y is 8 when x is 4, z is 1. So we can use these to find the value of k, the constant of variation. So we come here, y is 8, we put 8, k we don't know, x is 4, z is 1, it becomes 1 squared. Then we say over 1, that becomes 4k, then 8 times 1 squared is 8, divide by 4, divide by 4, that goes, then k is equal to 4 into 8, that is 2. So the value of k is 2. That's the answer. Once we found the value of k, we can write the equation like this. We can say y is equal to 2x over z squared. Now we have written the value of k since it's a constant. So to find for b the value of y, when x is 9 and z is 3, we say y is equal to 2, x is 9, z is 3, it becomes 3 squared. Y will be equal to, so 2 times 9 is 18, 3 squared is 9, and 9 into 18 is 2. So the value of y is 2. Then again the same equation, y is equal to 2x over z squared. This time they want us to find the value of z when y is equal to 3. So what are we going to do? So where there is y, I'll put 3. So 3 is equal to, x is 54, so 2 times 54, z I don't know, z squared, I'll say over 1 and cross multiply. This will give me 3z squared. This should equal to, what is 2 multiplied by 54? I get 108. Then I'll divide by 3, divide by 3. 3 goes, 3 goes. Z squared is equal to, how many times does 3 go into 108? It goes there 36 times. You square root, that goes, then z will be equal to positive or minus 6. So that's the value of z. That is the value of z. So that is how you can do questions on variation. Okay, proceed. We look at question 19. Now question 19 is the first part. We have an equation there. Solve the equation. So that's the equation that we need to solve. Now that one is straightforward. This is how we would solve it. So we have x to the power 1 over 3. It is equal to 9. 9 is the same as power 1. So we use what we call multiplicative inverse. The multiplicative inverse of 1 over 3 is just 3 over 1 or just 3. So I'll say x to the power 1 over 3. I'll multiply this by 3. And whatever I do on the left hand side, I'll do on the right hand side. So that the 3 and the 3 will cancel. Then this will be 9 to the power 3. And 9 to the power 3 means 9 times 9 times 9 3 times. So we get 729. So that is the answer for that one. Then part B, in the answer space below is an incomplete flowchart for calculating the height of a cylinder given its volume and radius. Complete the flowchart. Okay, this is a question on computer logarithms. So now specifically we have a flow chart here. How do we go about that? So they want us to complete that. So now, if we've been given, let's see what we've been given. So here they are saying they've given us, we are calculating the height of a cylinder. They've given us the volume and radius. So we're calculating the height, they've given us the volume and the radius. So what do you put now? Let's do that. We have that. This is what we have. So this is a rhombus, or we can say a parallelogram. So in a parallelogram, it's the input or enter. So this is why you input data. So you can say input. What are you going to put here? You input what you've been given. They've given us the volume and the radius. What is the next step? We are calculating height. Now, for a cylinder, when they have given you volume and radius, then how do we find the height? So you have to know the formula that you can use to go about that one. So which formula can we use to find the height of a cylinder when we've been given the volume and the radius? Very important. So this is what we're going to do. In most cases, you are familiar to finding volume when they give you the height and the radius. Now in this case, they've given us the volume and the radius. They want us to find the height. So we just manipulate the formula that we have for calculating the volume. For instance, the volume of a cylinder is given by pi r squared height. Now, how do we find the height when you have volume as that? We say divide by pi r squared divide by pi r squared. That goes, that goes. Therefore, the height is given by volume divided by pi r squared. But how do you write this formula here? This is how you write it. You say volume is equal to, or height I mean, is equal to volume. Then you say over, then you say pi star radius star radius. Then print h. So that's basically how you can do this one. It was a straightforward one. We look at another one here. So we look at another question. This is question 20. Now in question 20, we have points A and B have coordinates. So the coordinates of A and B, they want us to find the length. Now this question is on a topic we call coordinate geometry. It's a very simple topic. So how do we find? So when we've been given let's say point A 2, -3, point B 7, 9, what we say this is our x1, y1, x2, y2. Then how are we going to find the length? Now first of all, the length of AB is given by the formula, the square root of, so this is the formula we use to find length. So square root, then we say x2 minus x1 squared plus y, so this is the plus, y2 minus y1 squared. That's the formula we use to find the length. Then from there, where we know our x1, y1, x2, y2, we just proceed and we substitute. So this will become the square root of our x2 is 7, over x1 is 2 squared plus our y2 is 9. Then our, when we say minus, y1 is negative 3, so it will change to be plus 3 squared. Then that one is going to give us the root of 7 minus 2 is 5, then the 5 is squared, then 9 plus 3 is 12, then the 12 is squared. That will give us 5 squared is 25, 12 squared is 144. Then when we say 25 plus 144, we get 169. Then the root of 169 is 13. So the distance is 13 units. That's the answer. So that's length. That one was straightforward. Then we look at part B. Part B, given that y is equal to 4x to the power 3 minus 3x squared plus 5x, we find dy over dx. Here we are just differentiating. This is a topic on calculus. To differentiate that, so this is what we're going to do. This 3 will multiply 4, so that it becomes 12x, then the power reduced by 1 becomes 2. These 2 multiply 3, so that it becomes 6, the power reduces by 1, then that one will just remain as 5. Differentiating is very simple and straightforward. That is the answer. We go to question 21. Now, write down the 3 inequalities that define the unshaded region R on the diagram below. So this is a question on linear programming. How do we answer such a question? So how do we write 3 inequalities that define the unshaded region R? So the first inequality is this one, this one is a straightforward one, because if you check, this line is passing at the point where x is 7. This is a point where x is 7. So the first one, you say the first inequality is the point where x is less than 7. We are saying x is less than 7 because we're interested in this region, the less than part. So x is less than 7. And we don't put an equal to because the line is dotted. So that one was a straightforward one, but they're supposed to be 3. So in order for us to find the other one, we're going to get, okay, I can start with this one, which has the coordinates 1, 1 and 7, 3. I start with that one. So I can get the coordinates 1, 1, then and I get 7, 3. Then I find the gradient and the distance. So I'll say this is x1, y1, x2, y2. So in finding the gradient, you know that the gradient is found by saying y2 minus y1 over x2 minus x1. y2 is 3 minus y1, x2 is 7 minus x1. This is going to give us, what do we have there? So 3 minus 1 is 2, 7 minus 1 is 6, then 2 over 6 simplifies to 1 over 3. So the gradient is 1 over 3. Then we now find the equation. How do we find the equation? Now we can use this formula. So to find the equation, let's say y minus y1 must be equal to gradient x minus x1. Okay, So I'm going to pick these points 1, 1. So I'll say y minus, where there is y1, I say 1. The gradient is 1/3. Then x minus x1 is also 1. Then I just simplify that by making y the subject. So y is equal to 1/3x minus 1/3 plus 1/1. When this -1 crosses the cosine, it becomes positive. Then y will become 1/3x. If I simplify, what is -1/3 plus 1/1? I get positive 2/3. Positive 2/3. So this answer I've gotten is the other equation that we get. Is the other equation, but we need to represent it. How am I going to represent it? With a greater than, or a less than, or with an equal to. So now, since this is a solid line and we need this part, which is the greater than part, so we're going to represent it like this. So I'm going to say, so this is how we're going to write it. So maybe let me write it here. So I'm going to write it like that. The second inequality will be like this: y. This is greater than or equal to 1/3x plus 2/3. That is the answer. Then the third one, there's supposed to be 3. The third one, I'll get the points 1, 1 and 7, 7. 1, 1 and 7, 7. So this will be my x1, y1, x2, y2. Then even with that one, I proceed to find the same. I start by finding gradient, where you know to say it will be y2 minus y1, which will be 7 minus 1, and it will be x2 minus x1, which will be 7 minus 1, and this will be 6/6, which will give us 1. To now find the equation, I'll say y minus y1 should be equal to mx minus x1. Finding equation of a straight line. So I'll say y minus 1, if I'm getting these points, then must be equal to the gradient is 1x minus 1. So this will now give us, so I now simplify that so that it becomes y minus 1 is equal to x minus 1. Making y subject, it becomes x minus 1 plus 1. Then this becomes y is equal to x. Now y is equal to x. Which line am I looking at? Is this line, and I want this part here, the part which is less than. So I'll say the third inequality, I'll say y is less than or equal to x. So that is the answer that I have found. So therefore, I found all the 3 inequalities, where this was the first one, never had an equal to because it was dotted. These 2 have equal to because they are solid lines. So that's basically how you can go about this. We proceed. Look at another question. Okay, so we start from here, question 22. The components of the vectors OA and OB are 2, 3, and 4, 2, respectively. Okay, write down BA as a column vector. So now this one is straightforward, very easy. It's all vectors. So look at what will happen. They want us to find the vector BA as a column vector. So to find the vector BA, it should start from B, then it will end at A. So it will start from B, so it will be BO, then plus since it has ended at O, it starts from O, then it goes to the destination, which is A. Then how is this vector going to be? Now, if OB is 4 and 2, then BO will have a negative outside. Then we say 4, 2, then plus OA, we just get the way it is, which is 2 and 3. Then this is going to simplify as negative 4, negative 2, then plus 2, 3, which is equal to, then what is our BA? Negative 4 plus 2. So negative 4 plus 2, we get negative 2. Then negative 2 plus 3, we get positive 1. So that is the final answer for that one. Then we proceed to part B. The diagram shows the sketch of the graph. Y is equal to 3 minus 2x minus x squared. Okay, that's the sketch of this graph. Then what do they want us to find? They want us to find, number 1, Roman numeral 1, coordinates of the points A and C. So this is A here, this is C here. Now, as you can see, they lie on the x-axis, and we know that the value of y is 0 here. So we just get this same equation and we solve it. So what are we going to do? So I'll get the equation y is equal to 3 minus 2x minus x squared. Then I'm going to write it like this: y is equal to negative x squared minus 2x plus 3 in standard form. Then I find what we call the product, the sum, and the factors. The product in this case is negative 1 times 3, which is negative 3. The sum, I have negative 2. So what numbers are going to multiply to negative 3 and add to negative 2? So that is positive 1 and negative 3. Then these, I'll get them and I'll replace them. So this will be negative x squared. I start with negative 3x, then plus x plus 3. This should be equal to 0 now. While there is y, I'm putting 0. Then I factorize this first 2. So if I'm to factorize the first 2, what is common? So I'm checking in the first 2. We're going to discover that negative x is common. Then remain with positive x, okay, plus 3. Then in here, what is common is positive 1. Remain with x plus 3 is equal to 0. So you cancel one of these, you group what has remained. So that one, we're going to group it so that we have, what are we going to have? So we remain with negative x plus 1. Then we also have x plus 3 is equal to 0. Then from there, what we'll do from this one, we'll say the values now, want to get the values. So we'll say negative x plus 1 is equal to 0, or we have x plus 3 is equal to 0. So this will give us positive 1 is equal to x, or x is equal to negative 3. So meaning the one which is likely to be negative is where the a is. So to find the coordinates of a will be negative 3, 0, and the coordinates of c will be positive 1, 0. So that one has been dealt with. Then the other one, to find the turning points of the graph. So the turning points of the graph. How do we find the turning points? Okay, so this is how we're going to find the turning points of the graph. It's easier. So we have the graph. I'll get the equation. So y is equal to -3, or y is equal to 3 minus 2x minus x squared. Okay, I'm going to use that same one so that it can help me to find the turning points. Okay, let's see. So we come here, want to find the turning points. So I'll say the turning points are equal to the formula that we use for the x value. It is negative b over 2a. For the y value, we use 4ac minus b squared, everything over 4a. Then we need to find the value of a. Now from that equation that we had, now if we get it back, the equation that we had made an equation. It was y is equal to, in standard form, negative x squared minus 2x plus 3. So this was the one in standard form where a is -1, where b is -2, and where c is equal to 3. So we have that one in standard form. Then to find the turning points, now we come here and we substitute. We say negative, where there is b, it's -2. Then 2, where there is a, it's -1. Then we say comma, 4, where there is a, it's -1. Then where there is c, it is 3. Then minus, where there is b, it is -2, it is squared. Then everything over 4, where there is a, it's -1. And we cross. The turning point will be equal to, simplify that. So negative, negative. So 2 divided by 2, this will give us c. So negative times negative. Then the value of a, sorry, this is a negative. So negative times negative is positive. Then 2 times -1 is -2. So this will give us -1, comma. Then how do you simplify that? 4 times -1 times 3 is -12. Then minus 4, -12. We have -4, we have -16. Then 4 times, so this is a negative, 4 times -1, we have, so over -4. Then the turning points are going to be finally -1, +4. So these are the turning points. Then the last question now for this paper is a question on trivial graph. It's a question on trivial graph. How do we go about such a question? It's a straightforward question also, because sometimes there are more complicated trivial graphs. This one is a straightforward question. The following diagram is a speed time graph of a car. Calculate the acceleration of the car during the first 5 seconds. The first 5 seconds acceleration is given by the final velocity minus, we can say, speed over minus the initial over time. So it reached at the final of 20 when it started from 0. Then the time it took from 0 to 20 was 5 seconds. So 20 over 5, we get 4 meters per second squared. So that is the answer for the first one. Check if there is another one. Yes, there is. Find the value of t. Given that the total distance traveled was 550 meters. So how do we find that? So I'll do this. Distance is equal to the area under the graph. And what is this area? This shape is a trapezium. It's a trapezoid. And area of a trapezoid is given by half a plus b height. So now they've given us to say the distance is 550. Then I'll say half a plus b. So the distance from here to there, I'll say 25 minus 5, that is 20. So meaning this part will be my a, this one will be my b, from there all the way up to there. So now this one I don't know it because the final is t. So I'll say plus t. Then the height from there to there, the height is 20. So I'll say 550. Then I know 2 into 2 is 1, 2 into 20 is 10. So, and the 10 multiplied by 20 is 200. 10 multiplied by t is 10t. Then the 200 will cross, it will be 550. Subtract 200 is equal to 10t. Then 550 minus 200 is 350 is equal to 10t. Then divide by 10, divide by 10, that goes, then the value of t, 0 goes, 0 goes, then t is 35 seconds. So t is 35 seconds. So now that the value of t has been found, calculate the average speed for the whole journey. How can we find the average speed now? This is also the easiest part after you found everything. Speed is given by distance over time. So average speed is equal to the total distance they had given us as 550. Okay, this was meters. Then the total time we found 35 seconds. So if I say 35 into 550, so that 5 goes into 550, that is that into that is 1, that into that is 5, so it goes there 15 times, then it leaves a remainder of 5. Okay, so 15, 5 over 7. Okay, meters per second. So the calculator is not allowed to use, so you just leave it as a mixed fraction. It's okay, just leave it as a mixed fraction, and that is the average speed. So we are done with this paper. For those of you who are having challenges, you can get in touch with us on the line 0973415775 for any subject you'd want and any topic you'd want would be helpful. Thank you.